Good evening, friends. Today we'll be talking about something on application security. Why this is application security is so important? Why we are going to talk about this one? How does it been differentiated from the other security projects as well? Means like whichever we were discussing normally, cyber security, network security, physical security, like a lot of other security domains been there. Normally, we talk about the security, like firewalling, which we will do. A lot of rules and regulations will make it out. Policies we will write, right? No, that's from the network part of view. I'm just saying that. And if it is in the routers, Cisco routers, and other thing, we'll be writing some kind of access control list and all like. So we'll be blocking certain subnets, we'll be blocking certain ports and other things. So how does it being differentiated from the normal, conventional? Not conventional like that. I can just say that. It's about from the whichever we know about the security. How does it this application security is going to be a bit different about that? That's what I'm going to discuss this today. So this is gaining a momentum, and it has been there for last 3-4 years, maximum I guess 5 years and all. It has been there, and we talking about some kind of DevSecOps also, like the DevOps. We normally say that Agile is DevOps is in the DevOps. We are talking about DevSecOps means like development, security, and operations like that. So at the time of doing the development itself like that, we will be applying the security. We will take care of the security things as well, like, that is some part of like that. I can just say it's a common name. We can give it like that is an application security, because whatever the software we are going to write that in an entire SDLC cycle or something. So we just need to implement certain, security things and other things, because who can access, who cannot access. It's like an RBAC like that. You can just say, like normally we do it with LDAP or Windows AD, something like that. That is like, access level security only. But this is going to be like how you're going to write a software with security activated on that. And what is the procedures for that when you're writing it to make the lesser bugs, like the bugs which are there, which is causing. Because I've been working in other product manufacturing companies also, network product manufacturing companies also, like they are completely dependent on the code. They develop some code in the with their own platforms and other thing. They'll be developing the code and they will release it. They will be planning first and designing it, pulling out the requirements on this, then testing it, then releasing it. After releasing, it goes to the customer's place and all like that. Once it has been in the customer's place, once systems start working on for like 3 months, 4 months and all like that, it will be hitting certain bugs as well, because it is going to talk to some other vendor equipment as well. Like it's not only the same vendor network, the same vendor equipments will be connecting to this boxes or something like that. There are many other boxes as well. Like say, I can say from the network point of view, I can just say Cisco is one of the device, and then Juniper is another device, D-Link is another device, Extreme switches, like D-Link and Dell, EMC Square, IBM, so many other network devices which are there. Means like there are other application vendors also being in the market nowadays currently. So we are working on the clouds as well nowadays. So when we are trying to develop some kind of a software, in the sense, you just need to go through some kind of security framework like that. So in that security framework, we can call it as like an application security. So ultimately, what the development is making, it's making about the applications. That applications is going to stay back in any of our daily life. Maybe like some of the domains will be covered on this application security. And we've been very much known about the network security as well. Like now we are going to discuss about something on application security. So in this application security, there are many kind of a flowcharts which you are going to see that. Flowcharts in the sense, I'm not going to bore you, but there are many things which we need to discuss this. This is completely, I would like to tell you that this is completely a theoretical session. Like you can just say there is no labs I'm going to show you on this. Just a theoretical, because I'm just going through running these slides only, because it is talking about that how you are going to implement the security frameworks at the time of the development itself, before releasing the software outside for the customer utilizations like that. So end user like going to use that like that. So in the application security, what all the measures need to be taken, how the requirements coming up, what the design has been made, how the testing has been made on that. and how you are going to, like implementing the security features whenever there is a stage which is getting passed on that. Because I've been into this field for quite some time, so maybe I'm not dealing exactly the same way, but need to come across like a lot of terminologies about the application securities as well. So I thought I can make some small slides on this one. So because it is gaining a momentum, now we are talking a lot about the Docker security and the Kubernetes security that is coming into the DevSecOps. Everyone is looking for the DevSecOps. It is gaining the market now. There is a lot of application security engineers are required for that. So they can work on microservices security. That is nothing but a Kubernetes and a Docker. Podman is also being there. So at this stage like that, because see, when it goes to the cloud side, in the sense, cloud has got its own kind of a security patches, which has been already been that it has been already coming out with that certain framework which has been already installed, and the design has been happened on that. So AWS has got its own way of dealing the things. Azure has got its own but when we are developing our own software for our customers, it means any one of the platform, you can say that .NET or Java platform or any other platforms, you can say that. So in that one, I'll be discussing a little bit part of it. It's not going to be the entire application security which I can discuss, but I will just give you like some of the points which are there need to be discussed first. Then we'll go to at least one other chapter I can talk about. The one other chapter in the sense, I'm going to talk about the design level security, how the security design has to be made when we are developing the software in that. So, okay, it's just an introduction I just given you. Let's go back to the slides. Let's go and continue with the slides. Introduction. Why application security? Let me take my pen, okay? Why the application security is required? Why is security so important? Why is it so hard? It's hard in the sense, whenever it is coming to the security level, in the sense, it is going to be hard. Because we just need to go through a lot of steps and we just need to recheck it every time whenever it's getting implemented or something, whether it is running or not, perfectly working on or something like. So that is, it's about something about the introduction side. So most of the organizations at this point are slightly highly skilled at protecting the network perimeter, that is with the firewalls, which we already doing. Enterprise security, blocking the malware and not allowing the admin rights for the most of the users. Means we are not giving the root permission, admin rights to all the people. Only the administrators will be having it. And physical security, badging in and out secure areas. So we've been handling a lot of banking, like the NOC as well, SOC as well, means the security operating center. My batch doesn't work over there because I'm not authorized person to enter into that area. Because the people who are sitting on L1, L2 guys, they will be doing that. When the ticket comes to me, I will be handling it. That is a different issue. Okay, so it's like the badges which has been made for that only the certain persons can enter into it. That is a physical security. And giving the proper admin rights only for to the people who can do certain things on, like privileged levels. Then we're writing a lot of firewall rules. But even after doing this much of things, still, that said, reliable creating secure software is still an elusive goal for most organizations by today. Why? What's the reason for that? Even after doing this much, the things are still giving, it is hitting lots of bugs in the customer environment. Why? That is what the question is most asked everywhere. There is no 100% free like that. So completely free bugs software, though, it is not at all there. You cannot find anywhere. That is not possible at all. Somewhere, somehow, it will be hitting somewhere, but maybe there's some more workarounds will be there. And field notices may be getting involved in that one. So we just need to go through the field notices. Accordingly, we can just take some steps on that. And the bugs, when it's been hitting that, then we'll be calling the development engineers to work with us like that, man, see, this is coming up in the customer place. So how we will go for this? Maybe the memory leak or something like that. So there are many other causes out there. Okay, let's go to the next slide. And pushing left. This is what the people will be talking a lot of things. What is pushing left? You just see this here in this. Requirements comes in the first. Design comes in second. Coding comes in third. Testing comes in fourth. Release comes in five. Release is nothing but the deployment. Regress. So this is going to be the proper SDLC cycle. How the software has been developed in your own company with your set of engineers, developers, then when it is getting, what are the requirements of the software? what we require, what platform we look for, and what all the software core is required. The code is going to be written on which language, like that, which platform it has been developed, either it is in a cloud or local or something like that. Then once the requirement has been passed, then it'll go for a designing. How many users are going to get affected on this? Means like how many people will be getting it? What could be the scalability on this? And what all the, like where we will be, like what kind of customers are going to get satisfied by this kind of, the designs, like that is talking about the designs. Third one is the coding. What the real coding happening over here. Then after writing the coding, then you'll have to go for a testing. Testing is for like testing out everything, like whether it is working properly, what is being expected for that it has been working as such, is it giving the proper result for us, and it'll be working on the customer environment as well. Like that, we'll be going some regression, request tests, so many testing will be done on that. Then it will get released. So this is a normal cycle of any SDLC, system development life cycle. If you look at the system development life cycle in the figure, you see the various phases moving towards right of the page, right. This is right. Requirements come from design, which comes before coding. Whether you are doing agile, waterfall, DevOps, or any other software development methodology, you always need to know what you are building. That is nothing but the requirements. Make a plan. That is nothing but a design. Build it. That is a coding. Verifying it does all that it should do and nothing more. That is called the testing. Then releasing it and maintaining it, deployment, sorry, that is a deployment. So this is what like the original, the way the software has been developed on this. Everyone knows that developers must be knowing about this. Maybe I'm not developing the software as such, but I know that security implementations comes to us, so we should be aware of this. So this is nothing but a theory. Right? So this is quite common sense it's coming up. I'm not going to get deeper into the .NET coding and all that. No, don't worry about that. It's first the requirement comes in, what you are building. Then the planning is coming, that is nothing but a designing. Coding is happening, it's a building it. Then once it has been done, everything then go for testing, that is the fourth. Then releasing it, deploying it. Like that. So this is the normal cycle which we will be looking for. But what actually is happening is, let me go to the next slide. Often security activities start in the release or testing phases, where the security things has been discussed. Far to the right and quite late in the project, everything has been over, then the people will be doing certain, security things. They'll be looking for security. The problem with this is that later in the process that you fix a flaw, that is a design problem, or a bug, it is an implementation problem. The more it costs and harder it's to do. That is what the problem. This is called as the pushing left. This is called as pushing left. Once everything has been over, it's completely released, then the bug is hitting in the sense we'll come back to this. We'll do the testing. Then we'll analyze the code. Then we'll look for what kind of a design is being made. Then we'll go to the requirements, whether the requirement has been passed or not. This is like, it's going away from this. It's like kind of a reverse engineering that people are doing. It's actually bad and it is going to cost you so heavily for the company which has been developing it. And again, there is a whole set of the team has to sit down and to do the troubleshooting for all the customers as well. That is also involving like 24/7 activity, and how many customers has been affected on that. What level of an SLA has been assigned with the customers now. That is coming under the supporting environment now. We'll talk about the cost involved in this. How many teams are going to work with this? How many hours they are going to spend for these issues? Like that makes sense, because when you are developing it, when you are selling it, in the sense ROI has to come. Means like return on investment is so important. So once there is no gaining, that all the pain which ever been made, it goes in vain. Okay. That is what the problem is like that. So what is the solution for this? Security, we are talking about the security in the sense. So what is the security which we are going to discuss now here? Let's go to the next slide. What you must know to write a code safe enough to put on the internet. What all things you should be knowing them? Okay. What you must know to write code safe enough to put on the internet. Security fundamentals you should know. Okay. Just see that. Let me take the pen again. Security fundamentals, security requirements, secure design, secure code, common pitfalls. These all we should be knowing before writing anything on this. Then, what you should do to create a very good code and continue doing so. Testing and deployment, everyone is doing it. An AppSec program. Securing modern applications and systems, good habits, and continuous learning. These are all like the guidelines, you can just go through that. But anyway, these are all very important factors which we need to understand that even if whatever the network, sorry, it's only the network is coming. Whatever the developers who are just sitting down on that, just need to know about the security fundamentals first of all. They just sit down on a certain platform and start developing all these things, taking the code from here and there, modifying certain things, checking with the seniors and writing the code. That doesn't make profitability, because it's going to be, there will be a lot of flaws and design issues. So many things will be coming up. So to avoid the things before putting it on the internet in the sense like to give it to the public. So we need to know that security fundamentals, security requirements, security design, securing the code and the common pitfalls and other things. So we are not going to discuss everything on this, like this kind of a presentation slides which I made on that. I'm going to talk about only secure design. I'll be talking about secure design with this, because I just made some slides only on secure design on this. So in the design, I can say the design phase. There are many phases of that. We've seen that requirement phase, then coding phase, design phase, coding phase, and testing phase, like that. And then one other phase is that nothing but the design phase. In the design phase, what we will be discussing, what we need to take care. When we are implementing the security considerations, security framework at the time of the design itself, we can save a lot of money and time, and the customers will be much happier. But in practical, it's not so completely feasible, but still we can try for that. When we go through this kind of a framework, we'll be able to design the software in a proper manner that we can reduce the bugs, we can reduce the flaws, the level which has been on that. We'll discuss about the secure design on that. Let me go to the next slide. Secure design. When designing software applications, software architects not only need to worry about business requirements, what the customer has asked for. That is what the requirements. And the functional requirement, user requirement, scheduling, system requirements, like that. But also non-functional requirements that are often taken for granted, such as usability, quality, and security. Secure by design in software engineering means that the software has been designed from the ground up to the secure. Malicious practices are taken for granted, and care is taken to minimize the impact when a security vulnerability is discovered or an invalid user input. This is the design phase. Second phase, you can say. We are talking about the second phase. Requirements is the first, design comes in the next. So when we are designing the software applications, software architects not only need to worry about the business requirement, that is nothing but what customer has asked for, and the functional requirement, that is nothing but user requirements, scheduling, system requirements, and other things, but also non-functional requirement like usability, quality, security, and other things. So we will discuss something about these things in the coming up slides. Software design is the planning out how you will build your software and how it will connect or work with anything else need to. This can be very high-level document that shows how each part fits together. For instance, this front end connects to the database and also calls this API. Like that. Design documents can be extremely formal and detailed, down to the writing out which classes will be defined and how, or just few drawings and data flow diagrams. Like that. So this is about the design consideration. The purpose of the design document is to get across the team how to build the applications. So these are all just a theoretical thing, just need to go through. Okay, let's go to the next slide. So this is called as a design flaw. You see that? It's a design flaw. Flaw in the sense, it's a mistake maybe. You can take it as a design flaw, which causes a security bug. So design flaw and security bug, flaws versus bugs and other things. When it comes to this design phase, something like, you see that when you're doing the what the spending you're doing it, it's at below $10 something. It's just an example like that. Design flaw will be below $10. Negligible, you can just take it as coding flaw or a bug is $100. Testing $1,000. When it goes to the release and you started doing all this flaw and bugs in this stage, release stage, you will be having incident response and significantly more dollars need to be spent. Means in a sense, there is no, we cannot budget it over there. How much it is going to hit in the market, how much the customers are going to get affected, and what is the third party, the people who are implementing into that real customer environment, how much they're going to get affected. So that is, like insurmountable. I can just say the cost is so heavier, we cannot manage it. So when design, the problem is being called in the design phases called the flaw. When there is a coding issues, is nothing but a security flaw. Like security bug or something like that, it's called. So how you are going to solve this? That's why I just taken this, like the design phase to discuss about more on the more about the design phase. Like there are many phases. Every phase need to be discussed. Means like requirement phase, design phase, coding phase, testing phase, then the releasing phase. So all phases I cannot discuss because the time is very short. So I'll be discussing something about design phase only. It's in short, I can just say that when we try to reduce the flaws at the design phase itself, in the sense we can save a lot of money. Like once it has been released, in the sense when you're coming back to the pushing left model and all, it doesn't look like a professional model like that. So let's go to the next slide. When you make design changes in the last minute, they are not always pretty. They almost always make you miss deadlines, and they are often extremely expensive. That's what. Unfortunately, sometimes the last minute rush introduces a new vulnerabilities into your final product. That always happens. Hurry, when you do that, you'll be doing a lot of mistakes as well. So that is nothing but a pushing limit. At this stage, testing stages, releasing stage, you go back and try checking, in the sense it will take a lot of time. And there will be a lot of pressure will mount, because we just, like given the date for to get the releasing the software, in the sense it should be released. If it has not been getting released, in the sense there is a bug is hitting, flaw is coming up, it's failing in some stage, then you go back and start searching, all these things will be completely tensionless. So what should be the considerations we need to do it in the security design phase? Okay, we'll see that. Secure design. Okay, what are the concepts? In the secure design concepts we'll be discussing. With this in mind, with all these things which we discuss now, let's talk about several secure design concepts that should be applied, or at least it should be considered. That is what been expected. And designing the software applications, you see, this is some very valid points of that. We will be seeing one by one point in the different slides as well. This is like a bullet points, so just take that. Okay. First one, we'll talk about the protecting the sensitive data. Second is never trust, always verify, zero trust, assume the breach. Anytime the breach can happen. Backup and rollback is normal. Administrators, people will be doing always a backup. Server-side security validation, framework security features, security function isolation, application partitioning, secret management, re-authentication for transactions, that is nothing but avoiding the CSRF, protecting the source code. So these are all the topics which we will be discussing in the coming up slides. So these all things will be discussed in the secure design phase. First, we'll be talking about something on protecting the sensitive data. What is sensitive data? We'll go to the next slide. Protecting sensitive data. We have to talk about the CAA triad. What is that? Confidentiality, integrity, and availability. That we'll always talk about that. Security people will be speaking about this one only, CAA. When handling any data, we want to ensure that we maintain its CIA. It must be available when we need it. That is an availability. And it must be most accurate. That is nothing but integrity, sensitive or not. If the data is not public or unclassified, then we'll have to must also protect it to ensure our secret remains secret. There is nothing but a confidentiality. Okay. When data is sensitive, we need to find out how long your application is required to store it and create a plan for disposing at end of life, EOL. For example, if you must keep a data for the time period of 7 years, and after receiving it, then your system must destroy each record of data and automatically after 7 years. Design this into their application. Do not assume the users will be remembering to dispose it. They will not do, never do. So we just need to have some retention policy as well. How long is going to be there? Or we just need to have some destroying policy as well. 7 years in the sense. 7 years it has to be completely removed. Then you should be able to be, like get an email or something. So you must also design a verification data that has been destroyed completely. Also, do not forget how plan, do not forget to plan how the data will be removed from your backup systems, including any duplications or backup systems that may be existing. This is like protecting the secure data security. How you are going to protect it? So this is the first point we discussed. We'll go to the next one. Never trust, always verify. Zero trust, assuming the breach. Only use server-side trusted data. Data that has been properly validated to make access the control decisions. Deny by default. All functions should check to make sure that the user is authorized before proceeding. These are all nothing but a normal access list. I can talk about that. Server-side encryptions. Deny by default. Always fail closed or fail safe. Never fail to an open or unknown state. Always roll back if the transaction is not properly completed. These are all applicable for our all e-commerce sites and other things. Verify the identity, that is authenticating, then authorizing, access control. Re-verify the access on every page and feature of your application, even on reloading the page. Oh, beautiful. And verify the authentication and authorization for the APIs, both ways like that. So it goes in this way. API to application, application to API. Both back and forth again. This. Block access to any protocol, port, HTTP, verb, method, and anything else on your server. PWS or container that your application does not use. Block that. One application per server, PWS or container based on your deployment model and budget permitting. This is very important points in our life. So when you verifying the authentications, block anything unnecessary. One application per server. Don't put all the applications in one server only. So once it has been hacked, in the sense everything has been hacked. So try to keep some different, at least the containers, you can just need to keep it different so that if one container has been affected in the sense, other containers will still be free. So we can take some remedial actions over there. Okay. So this is about never trust, always verify. Anytime that can be breached. So you just need to be ready for that. Okay. The next we'll go. Backup and rollback. Backups are not valuable unless you can roll back to them efficiently. It is like rollbacking things. Like if it takes 1 month to roll back, that's a month of work that is being lost. It is absolutely essential that your application not only has backups as part of the design, but quick rollback of data and restore the systems. Backups must be stored in geographically different locations than your database and web server. This we normally do it in AWS. Backups must be in secure location, both physically and digitally, and protected just as you would protect your production database or web server. Schedule a rollback practice at least once a year. When there is a major changes to the production systems, ensure a rollback script has been made or tested. Your database, your configuration, your application code must be backed up completely. Access to your backups must be monitored, logged, and alerted upon. Yeah. So we have only the authorized persons will be getting the backups. Other people cannot touch it at all. Even if they try to do so, the root administrator will be getting a mail. Deletion of the backup should be time delayed in case because there is been deleted as part of an attack. Some cloud providers do this by default. Suggested timeline. Schedule the delete to occur 14 days after the request of deletion of the backups on any production database. So this need to be So this is just a guideline they given it, but it differs from company to company. Okay, it cannot be so strictly like saying fundamentals. It's depend on that. Practice the rollback seriously. Okay. So we've seen some backing up and rollback. This is also like security design concept. Let's go to the next slide. Server-side security validation. What is this? When performing an web application security testing, such as penetration testing, most testers use something called a web proxy or intercept proxy. Web proxy or intercept proxy. Sometimes combined with the web scanner to allow you to do the automated testing as well. A web proxy, as the name implies, it sits in between your browser and the web server, intercepting your traffic. If you write a validation code into your JavaScript to make sure that the user input is safe for your application, then that is fine. But if your application does not validate the data on the server, attackers can easily send your application a malicious request using the web proxy. So this is normally we call it as like MITM, man in the middle attack. Something like that comes in. Although it may seem expensive to send every validation back to the server side, it is guaranteed to be less expensive than having an attacker successfully exploiting your web application. That is what a little bit more money need to be spent on security devices, security techniques, security frameworks as well. And like so that you can able to less money after things has been done, damage has been done. Then when you try to recovering it, it may be taking a lot of time because nowadays we just seen some AWIMS and Delhi has been attacked with heavy, and they are asking some lot of money. So it's happening everywhere, every day, every hour, somewhere something is happening. So browser, this is just an explanation like that, how the typical GUI like that. So it's been shown browser JavaScript validation. Original request goes in, the web proxy attacker has been built, and he modifying the request and sending it to the web. So they can do anything they want. They can intercept everything, all the traffic and everything, they can do that. So better you validate it from the customer, validate it from the server side, then it's authenticated source only, it has been always accessing the server like that. So every time, whenever it has been refreshing the pages also, it has to be done. So this is one of the design concept on the security design. We'll go to the next one. Framework security features. We should never write our own security features if they exist in our framework. If they do not exist in our framework, we should evaluate carefully before we decide to write one for ourselves. If there is a commercial, affordable, and trusted upon option available, we should probably use that before writing our own. What is saying that you don't write your own security code on online. When it's available in the sense, you can start using that. For example, there are many different secret stores available that are free or priced within the reach of most organizations. That is secret stores. Figuring out how to store the secrets without storing them in your code is very complex problem. So using a pre-made solution almost always makes sense. That said, if you have a very special and unique situation, sometimes there is no other choice than to write a custom code. Don't write anything custom code because custom code has got so much vulnerabilities as well. Then we'll have to sit down to sorting out all these things. Perform an option analysis activity before you take making such a decisions on that. A secret store. What is secret store? Is where your application secrets live. It is not like a password manager, which is for human users. The secret store is used by the machines. You can and you should store your connection strings, credentials, keys, hashes, and other secrets in the secret store. So what is a guideline in the sense like that? Don't try to write the security framework on your own for your own code because there are things that are available in the market. We can go with that. We don't need to spend the money on that. Okay. This is just a consideration again. Okay. Let's go to the next slide. Security function isolation. What is this? Whenever possible, isolate the security functionality from other functionality in your applications. This applies to the hardware design as well. This means if someone breaks the non-security functionality, it won't affect your security functionality. Means you just need to bifurcate the things. Don't mingle up everything in single server. These are all normally the administrator people will be designing all these things properly. Anyway, for each security control, we separate the code or functionality. We can do this by putting into the separate object or a class on a different page or a dashboard within the application system and our separate applications together. Very, very much beautiful line. For each and every security control, we separate the code or a functionality. We can do this by putting into the separate object or class on a different page or dashboard within the application or stream and or a separate application together. We would likely also force the user app to re-authenticate before allowing it to access the security functionality in order to enforce this requirement. These are very, very beautifully written, like the sentences. Just need to go through the, maybe just need to buy out all these things. So examples of this include putting input validation in separate object or class when you're writing the code, putting authentication and or authorization into separate applications, identity management performed by your cloud provider or any other external system. So this is isolating the security functions as well. Right. So let's go to the next slide. Security function isolation continuing. The level of separation depends upon the sensitivity of the application you are creating and the power of the security functionality. The code for a security function could be stored on a separate web server, PWS, container, or a file system. There could be firewall between the two applications or completely separate networks in extreme cases. So keep it as in a different subnet as well. That is easier. Ensure that your identity authentication systems lives in a separate server and follows the hardening gate. Always do this one, no exceptions. Examples of security functionality that should always be isolated include security related logging and monitoring, intrusion prevention and detection, web application firewall, application control software, and file integrity monitoring, alerting, blocking, everything we can do. These all things need to be done. So this is about something called as an isolation. When this has been isolated properly, in the sense troubleshooting is also very easier. It doesn't get messed up with them. If there is a different container is there, a different file server has been there, different software application has been there, and the different servers, in the sense it is very easy for us to isolate it. And the problem can be solved out so quickly. We don't need to worry about that. We don't need to mix up with many other things in the same time, simultaneously like that. Okay, let's go to the next slide. Application partitioning. Whenever possible, isolate system management admin functionality from other functionality in your applications. This means if someone breaks a non-security functionality, it won't affect your system management, that is an access control functionality. Similar to the previous entry, this is about separating the functionality, except this only applies to administrative capabilities. If there is an administration portion of the application, that functionality is in a separate object or a class on a different page or a dashboard and our separate application. Preferably, users would need to log into the separate set of credentials with MFA enabled, multi-factor authentication, in order to administer your applications. So think about that. There should be a different dashboards has to be given. For software developers and other things, there should be a different dashboard. Administrators has to be having something. Users should be having something so that we can able to, like this is nothing but a partitioning comes in. The screen should not be similar for all the people. Like the same screen, if you go there, very easy for attacker to come up and attack your things. So try to do some partitioning and keep some different dashboards as well for each and every other access. Secret management. Next. When an application logs into the database, the connection string it used is a secret. When a web server has a certificate and key pair, that it uses the enabled HTTPS encryption for a web app, the private key of your key pair used to the certificate is secret. Private keys, API keys, hashes, passwords, anything else that is confidential that is used by the application, not the person or a user, is considered as a secret. What is secret? These are all the secrets. Secret management, when performed manually, is awful. We cannot able to do that. So it is a time-consuming, complex, and error-prone. Manually means awful. So it is error prone. This is why industry created secret stores. We already seen that. Software that manages this for you, that can be accessed programmatically from your application, your CI/CD pipeline, continuous integration and continuous development pipelines, or from a service account. Human beings should never access the secrets in your secret store, except when they are first put inside, when they are being updated, or in case of an emergency. Access to the secret store should be guarded carefully, monitored, logged, alerted upon. This is very much required. A good secret store should provide warnings to when your certificates will expire and provide details as to when secret was last rotated. Secret managements. So we normally go with that, like a server level certifications. We just need to do that. So that should be an alert management has to be there. How many servers has to be updated properly? Like HTTPS certificate, keys, hashes, passwords. So that is nothing but a secret stores. We just need to maintain that. Okay. Next one, we'll go for a re-authentication transaction, avoiding the CSRF. CSRF is nothing but cross-site request forgery. Is a vulnerability where an attacker convinces the victim to click a link or to visit the malicious website. This is happening everywhere. WhatsApp, you will be getting thousands of links. Emails, you are getting thousands of links. And Facebook, Twitter, wherever you go, there will be links and links and links and everywhere. The people doesn't understand if they're not quite good enough in understanding the things where it is actually originated from there. Whether the link is legitimate, whether I can click this link, where it will take me, what it is asking, what sort of an information it is looking for. So there's a very important and very much damaging thing that is nothing but a CSR. The link site triggers a transaction with an application. Within an application, let's say the purchase of the fancy new TV to be shipped to the attacker, something like that. And because the user was already logged into that account, he never logged out. You see the browser is open for the days. The vulnerability web application completes the transaction, means it is doing the purchase, and the user is none the wiser, means it doesn't know anything at all until the bill arrives. When the bill comes, he'll come to, oh man, someone has taken my account. They use my credit card, they use my debit cards, right? They use my GP account, something like that. But by then, this is too late. How to avoid this? Best way to defend against this is that asking the user for something that only could user provide before every important application action. That is nothing but purchasing, account deactivation, password change, and etc. This could be asking the user to re-enter their passwords, completing the CAPTCHA. Very most, like people doesn't like it. CAPTCHA means they would like to pass on the screen. Or for a secret token that only user would have. The most common approach is nothing but the secret token. Okay, often referred to as that anti-CSRF token. So it is so common of this writing that many modern frameworks, that is nothing but a .NET, Java, Ruby, and Rails and other things, perform this action on behalf of the programmer. So there is no need to code this functionality yourself. Verify if your framework has already been doing this for you, and if not, ensure that you are enabling this within the framework. So CSRF is the most damaging thing, because end users are not much educated about that, what things they just need to. Whenever there is something filling upon your spam folder, just don't go and click it out. That is most dangerous. Okay, let's go to the next slide. Protecting the source code. We come up to the last thing of that. The code you write for organization has monetary value, definitely. And potentially other types of the value, such as competitive advantage, governmental secrets, etc. It is highly likely that your organization would like to protect the code you write for intellectual property related reasons. That is nothing but, however, some companies publish their code on the internet for all to see. That is nothing but an open source. Okay. There are pros and cons of both the decisions. So either you keep it open or you would like to close it. Well, it means source code like. Many in the open source community argue that if the code is there for all to see, that people will notice the vulnerabilities quicker and more often in open source projects. Means if you keep it open in the sense that people will Everyone will be downloading and start utilizing it. So they will easily find out that, because there is a audience is so much, so many people are there. If it is kept as open source, everyone will download. So if it is free, means everyone will go and take it. That's what. So once they're taking it, they are the consumers. They immediately find out the flaws and vulnerabilities and other things. They'll come back and report. So we'll go and fix it very fastly. However, the numbers tells a different story. You see that? That's not the problem. It's telling the different story. Studies have shown that proprietary, that is nothing but a closed source application, have an average the same number of vulnerabilities as the open source projects, because whoever is writing, either it is an open source project or a closed source project, is the same person. So they'll be making the same, like mistakes and all. On the flip side, if an attacker is targeting you and your code is open source, this means that they have all the time in the world to review it for vulnerabilities. The defense is not bulletproof. It is simply one of the many potential layers you can use to protect your application and intellectual property. It's like that. Protecting the source code. Whether you keep it as open, everyone will be downloading and they will start finding out the vulnerabilities in there. Else, keep it as like a closed source or something. So this is nothing but like the layers of the security need to be implemented properly, so that you will be able will not be like hitting the road on every other point or something. So these are all the like the application security design phase I would like to discuss on this. So there are many other things need to be discussed in the sense in the on the application security level. We have a lot of other things need to be discussed. There are many phases are there in this. So we've seen some requirements and designing and coding and testing and testing and releasing and other things. So every other phase has got its own kind of, like bullet points and explanations, examples, everything has been there. So in this 10-15 minutes, I cannot discuss everything on this. Okay. So that's all from my side. So application security, because it has been coming up in so much in demand nowadays, because I've been working with DevOps and other things, and DevSecOps we've been working on, Kubernetes and microservices and other things and all. So as usual, you can call me or WhatsApp me on this number if you'd like to listen to me about more on application securities, not only on application security. Either it is a routing switching or cloud related courses or firewall related courses or microservices and other things. Like the firewalls, everything, like all network related things, because I'm a network architect, I can able to help you. I can connect some courses for you when you're looking for. Okay, SD-WANs and other things and also I'm talking about, because I've been having a lot of experience on the networking industry. So I can talk about all these things. So you can subscribe to my channel. As usual, I'm just asking you. YouTube channel, I can subscribe to that, and you can refer my channel to your friends, relatives, and colleagues. You can call me, WhatsApp me on this number. You can Skype it to me on this. The code ID has been given on this. So once again, thank you for joining today for this application security. I'll be doing more on this in the sense like some other interesting chapters like this, maybe in the coming up weeks. Thanks for joining, and we'll meet together later. Thank you very much. Bye.